All right, good evening. What a good evening it is, too. A wonderful evening where we can welcome Angie Ohman from the great city, New York.
Hi,
Welcome, Angie. Lovely to see you. Thank you for giving of your time this evening.
thanks so much for having me.
Right, everyone, just so that you know, let's touch on the admin arrangements. At the end of the evening, you will, of course, have a chance to ask questions. And concurrently, as you're asking your questions, there'll be two surveys for you to complete. The first one being for the BHS School of Lighting survey, and the second being for those who claim CPD credits, continued professional development credits. That's a very important one for you to complete. At the end, you'll receive an email from the system that we've prepared. You will also receive your certificate of attendance and a feedback form and a link to the recording. So those of you who, particularly those who sign in a little bit late, can watch from the beginning. So before we proceed, as I welcome Angie this evening, Angie's interest in lighting began in architectural school and continues to fascinate her still to this day. By its dynamic ability to interact with materials and change a space. She aims to increase awareness and interest in light's impact and potential among architects, designers, and end users. In 2018, she wrote and illustrated Lighting Intuition for Architects in collaboration with her colleagues at Renfro Design Group to help make basic lighting, the basic principles of lighting and design more approachable and accessible. She's been at Renfro Group in New York City since 2017, working as a project manager and designer on a variety of projects, including museums, historical sites, high-end residential work, and office spaces. Recent projects include exhibits and spaces at the American Museum of Natural History, New York Public Library, and the South Street Seaport Museum. She received her Bachelor of Architecture from Rensselaer Polytechnic Institute and a Master of Science in Lighting from Rensselaer Polytechnic Institute's Lighting Research Center. She was honored to be named as one of the 40 under 40 recipients in 2022. So, Angie, a very big welcome to you.
Thank you so much.
Thank you.
All right, well, I will begin. So, as Phillip introduced me, I'm at Renfro Design Group here in New York City. We are a small to medium firm, depending on how you categorize it. We have about 9 designers and 3 different teams working on a variety of projects, but many of them intersect with museums or civic projects, lots of public spaces, and then some high-end residential spaces as well. And about 5 years ago, actually 5 years ago, the beginning of September, we celebrated our 20th anniversary, and we had a celebration party. One of the things we wanted to do was give away some sort of token of our thanks and gratitude towards all of our clients and collaborators, all the architects and engineers we work with who are attending the party, who may not attend the party, but we wanted to send them something as a thank you. And this book was born. And the book, originally we were thinking, we'll put something together of all of our projects, pretty images of the final project. And what we've found is we've received some of those from architects, and they're beautiful books, but we hardly open them unless we're referencing a specific project. And so we thought it would be fun to give someone something that they might open as a reference and might be actually helpful for them in kind of their daily work, or just intrigue them and kind of want to learn more. Not everyone is as obsessed with light as we are, and we know that, but we'd love to kind of give people an intro to some of what we work with every day, some of what fascinates us. So this book was born as kind of an ongoing collaboration. Part of collaboration for us is just education about what light is, what the surprises of light are, how it interacts with materials especially, and then just things that are not necessarily intuitive unless you're working with light every day. So this is kind of our ongoing collaboration. What we've also noticed with especially architectural projects and the publicity of architectural projects is that light is often something that gets photoshopped out. We see projects during the day and all the lights are magically gone. There's these magic lights that must light the space at night, and you can't see them during the day. Our hope is always to design a space that the interior designers and architects don't feel like they need to Photoshop the lights out. You can see this is all the same project. It's not one of ours, but it's a beautiful space. And the left images, there are no light fixtures in that ceiling, but on the right you can see at night there are light fixtures in that ceiling lighting that kitchen, and they're gone from the renderings. And so part of us, advocating for integrating light within architecture requires a lot of collaboration, making sure we can hide the light sources as much as possible, make sure we're lighting the space, but really not seeing the light fixtures, which is difficult depending on the project. And so any education and collaboration we can do to make that easier, we really want to do. So I'll go through, there's a little over 30 kind of tips in the book that we illustrated. They're just kind of a taste of some of the lighting concepts that we work with all the time. And I'll go through, I think I've got about 15. So no means an exhaustive list, and the book is not an exhaustive list of everything we know about light, but it's a taste of what we enjoy learning all the time. You'll also notice if you look through the book, all of the pages are available on our website. You can order a physical copy as well. But you'll see that the numbers skip a lot, and we know that we don't know everything about light yet. And there's a lot more that can't be illustrated. So you'll see kind of a lot of gaps that may be filled in a volume 2, which I'm ever so slowly working on, and may just not be able to be illustrated. One kind of project type we work on a lot are museums. And one of the main issues we see with museums is just art lighting positions, where that light is when it's lighting the artwork. Specifically for artwork on the wall is kind of the most complicated at times. And so this illustration kind of what happens when the light is too close. You have, especially with thick frames, this happens a lot with older artwork with these beautiful ornate frames. It can really cause some distracting shadows on the artwork itself. We really try to avoid that. That close angle of a grazing light can also maybe create some texture you don't want to see in a painting. It might be a distracting texture. If it's too far, you may have a different problem where if you have a painting, or especially something with glass on the front, you're getting a sheen and a glare on that painting that's really distracting, and it's preventing you from seeing the full artwork. And if it's even further back, if you're standing in front of that artwork, you're going to end up shadowing it. And so there is this kind of sweet spot that we look for that's all about angles. And so I think that angle we kind of keep in mind all the time. We're usually targeting 33 to 35 degree angle from the wall, but it's always a collaboration also with the curators, with the art consultants. So a couple illustrations of what this can look like in real life, not just in illustration form. The left side is from a museum here in New York, and sometimes you don't have a great fixture position, it's unavoidable, but when I saw this painting, I originally thought, oh, there's some really deep storm clouds in that painting. And then at closer glance, I realized they were happening below the frame as well. And on the right, you can see this is a picture of what the image is. kind of from the website, from the curation. So it really distracts kind of what that painting's seen as. And so sometimes this is unavoidable, but we really try to make sure this isn't, we don't want the light to distract from the artwork if at all possible. So that angle is really helpful for making sure the artwork is put in its best light. And then on the other side, if we're too far, we have problems with glare. This is a little bit dissimilar. There's linear fixtures in this gallery, but you have glazed artwork, and you can have some really distracting glare on it. Salon styles are really difficult because all of the art is at different heights, and so you've got lots of different angles. You may not have all of those positions, and so you can see it's a little small, but the center of this painting, you can't really see the bust at all because it's kind of in glare from the fixture that's lighting it, and similar to some of these landscapes at the top, it's at such an angle that you really can't see the painting unless you move around it. So that's kind of our main artwork tip. One of the main things we come across is just materials and light, some of the surprises of materials and light. I am always asking questions about what material space is, a floor is, wall is, because it's really important to understand how the light might interact with it. So this is sort of a collection, a small cross-section of some of the surfaces that we find are common issues to light, something that we've been asked to light and we say, I don't know that that's going to appear the way you want it to appear. And just from kind of our work with different materials, we kind of know, at least at a glance, how to anticipate what some of that might look like. So often we get asked to light a mirror, which doesn't really work. You will see the mirrored image of the fixture, but you can't really light the mirror. You can light the dust that collects on the mirror, but it's usually not the way they want it to look. Similarly with clear glass, if it's dark on the other side of the glass, it will act almost the same as a mirror. But if it's clear, you're lighting through the glass into the space beyond. This can be really problematic for light pollution if it's interior fixtures lighting to the outside, or if they want kind of a facade to light up and be bright. If they're just lighting the glass, it's not going to happen the way it might be anticipated in a rendering or something that's not tied to a mock-up. Similar with polished surfaces, there's just a lot of surprise polished surfaces, tile, other metals, anything that's shiny. We can have polished plaster that has the same issue, where you're really seeing the brightness and the image of the fixture mirrored, but you're not really getting the effect of the light on the wall that you want. Stone is the same thing. We often advocate for a honed finish on stone if at all possible, just because it gives us a lot more flexibility to kind of evenly wash the stone. Sometimes it's not possible. And then anything black is just really absorbing all of the light. And so I remember very early on in my career, I had helped design an office space and was doing the punch list. And all of a sudden, the bathroom was black, and it was supposed to be white in the original design, but the interior designer had made a last-minute change and had all black ceilings, walls, and dark floors, and it absorbed almost all of the light, and it just appeared very differently. We had kind of a wall wash going down the wall, and it wasn't as anticipated. And so we really advocate for everyone understanding how finishes interact with light, just so everyone knows what to anticipate, so there's no surprises later. And then one of the main surprises that I think is the least intuitive, from a swatch, is a brushed finish. This will happen especially with stainless steel, where the direction of the brush makes all the difference in how that light is captured. So what will happen with the brush is if it's parallel to the source, every single little ridge of that brush will reflect the image of that source. And so you'll get the striping effect. So in this picture, the source is running parallel to the direction of the rib, and you're getting that very dramatic stripe. The sample on the right is more of a satin finish, so it's a little bit less noticeable, but it's still pretty dramatic. And these are the exact same samples, but rotated 90 degrees. So the brush is going perpendicular to the direction of the source. It's the exact same source, and you're not seeing that same striation. And even the dots of the fixture are not as noticeable in the sample. We see this a lot with like kitchens or other surfaces that want to be brushed. We really make sure, if we can, to do a non-brushed surface because there's fewer surprises later, but sometimes things happen. So one project where this happened this is an entry to a nonprofit foundation that has a gallery here in New York City. We had a concealed fixture lighting across a door just to kind of indicate where the doors were. It's a historic facade, so it's kind of limited intervention. And the original sketches, all of the sketches past that, always asked for a matte surface so that we could hide and conceal the fixture as much as possible, make sure it's a nice even wash of light. But when the final install was revealed during construction, they had a brushed finish going top to bottom, with the fixture going top to bottom, with visible diodes, and we had stripes, which sometimes we had one project where they really liked the stripes. That was their concept for the facade. They really wanted that, so we worked with that. This was not one of those projects, and so we had to go through a pretty extensive problem solving to make sure we could solve that problem. So these fixtures were baked into the waterproofing of the facade. So we had to leave the wiring in place, find a manufacturer that could work with the same wiring, fit the fixture into the existing mounting clips that were there from the previous fixture, and it became a really big kind of backwards problem solving solution. But that transparency of what finish that material is, that conversation we always try to keep active because it prevents a lot of these issues in the future. When it came out, you can see the much softer glow on the side. It's a lot less distracting than the striation. Another very similar issue is anything that's a woven fabric, woven stainless steel cables. I find these used a lot in elevators. It can be a great material, really durable material for the walls, but it has that same striation effect where every cable within that weave is repeating the image of the light source and can have these kind of very dramatic angled stripes. And sometimes people really are going for this, and that's great, but I think knowing and anticipating that that's going to happen is something that doesn't always happen. So this was a space we did not design, but was in a building that we were working on. So we found this a little distracting. It's not to our taste. It may have been to the taste originally. I'm not sure, but it's definitely a graphic that you need to anticipate is going to happen when you have those woven materials. Kind of going back to some of those other surfaces that were difficult to light. So this is on the left is a black hallway. If you are lighting kind of down a black wall, most of that wall is absorbing the light. You're really just seeing the brightness of the source at the top and not much through the bottom. And if you want kind of that neon effect, this can be great. Maybe you don't want the light to travel down the wall, but if you are anticipating a bright lit wall, black will not achieve that. And then this was from a mock-up in our office. We had an architect that wanted to light an elevator lobby that was glass clad. And so we were showing them that if we do have light fixtures next to the glass, we will see the image of the light fixture in the glass. And if it is ribbed, it sort of masks the image of the fixture, but you're really just seeing the brightness of the fixture itself. So again, sometimes people want this look, but we really advocate for mock-ups because sometimes materials do not interact the way you anticipate. These are a few snapshots from a project that was using kind of a wide variety of those finishes. On the left is a honed stone that they used for the lobby, and there's actually a shinier stone in the back. And they really liked the way that this was sort of matte, absorbed the light. Light bounced off of it really well. It felt like a bright material, but it wasn't distractingly shiny. And on the opposite spectrum, we really used specular to reflect the images around it at the lobby canopy. So this is a mock-up of that canopy. The canopy would extend to the exterior, and so the idea was to pick up on all the movement of people, taxis, cars that were coming by and coming into the lobby. So these are a couple of final images from that project. This is that canopy extending outward, and all of the base fins are that mirrored finish, that mirrored chrome finish. And here we really lit the space above those fins. We didn't light them directly. Everything is indirect above them, with some direct fixtures for emergency access. And you really get this wonderful reflection of everything around in the city. Another image of that entire lobby. And then this ceiling had a slightly different textured finish, and then you have the honed stone on the walls. So understanding finishes and how they interact with light can make really beautiful projects, really successful ones, but mock-ups are really helpful. Similarly, just the surface of anything above a fixture, indirect sources can be a really great way to light a space, make a really soft, diffuse light source. But you have to kind of keep in mind the finish above the source. If you're relying on an uplight condition, and you have a dark ceiling, you're not going to get much light out of it. We see this especially if we're relying on that for task light or for emergency egress. We really want to make sure we know what material is above that fixture. And then sometimes the surprise is that a shiny or specular surface is above the fixture, and many of these indirect fixtures are not meant to be seen from above, and so seeing kind of the guts of the inside of the fixture we want to avoid. So this was a project kind of existing conditions in a home, and we were noticing the polished plaster was sort of revealing the insides of these chandeliers, which sometimes the inside of the chandelier is a really beautiful perspective on it. These ones were not really developed to be seen from the top side, and so we found it just a little distracting. Switching gears, one of the things that we really enjoy working with is just the way light changes throughout the course of the day, daylight specifically. That at peak intensity, midday, the color temperature shifts cooler and is warmer at sunrise and sunset. And so I think circadian rhythms and understanding kind of tunable and dynamic white spaces is getting more and more common, which is really exciting. We actually test this on ourselves in our office, which was designed, I think, almost 10 years ago. And we have a show that plays throughout the day that shifts the color so it matches the color of light outside, or better matches the color of light outside, which is really fun. And I think it's something to also keep in mind for projects that have a lot of daylight, that all those finishes might be seen during different times of the day and with different color temperatures as a reference. And then similarly, during the day, daylight has, really wonderful color rendering. It renders colors true to the right shade and hue, but the electric light might shift that at night. Different sources will really render colors differently. And so it doesn't always happen, but if it's possible, we really love to help the interior designers or architects see, what their color swatches or materials look like under the actual light source that's anticipated, so they can choose colors and don't get surprises when it's built. So one project we kind of used both concepts on was this executive office, and it kind of made me nervous that they were choosing such a dark gray for the space. It's not usually what I advocate for. But they wanted to make it more of a residential space, even though it's in a corporate finance office. And the lights that were chosen here do shift color throughout the day. And so there are 2 walls of windows facing east and facing south. So they get quite a lot of daylight and quite a lot of shift throughout the day. And so these lights kind of automatically, with one of the settings, would shift warm in the morning, cooler midday, and then warm up at night. And when the interior designer was working on this with us, we actually had her bring her swatches to the office, and we had the light source with us and looked at different color temperatures and how those sources or how those finishes would render. And she actually shifted a couple choices because she said, oh, this gray looks great during kind of that midday color temperature, the cooler color temperature, 4000 K, but it looks really muddy under warmer color temperatures. So I'm going to kind of tweak that. And on the top, you have the space. Of course, your phone camera adjusts the white a little bit, but you can see just how different the colors look at 4000 K versus somewhere around 27 to 3000 K, especially the reds. I think one of the common misconceptions we find with LEDs is that they last forever and they never die. Unfortunately, it's not the case. And sometimes there's failures early on in its life. It is an electronic product, and I think there's always kind of a dud that will happen, or sometimes a failed install. And so we really want to make sure we advocate for maintenance, even if they don't anticipate maintaining it soon. We want to make sure it's not an absolute headache to access. And so some of the tall ceilings, some of them are accessible by ladder. Maybe that's easy. Sometimes you have a chandelier that needs 2 people and it's hard, you can't really get 2 ladders in there. So all of those considerations apply. Often the lift, a lift is a solution, either a scissor lift or in larger spaces or exterior spaces, a boom lift. But these are really heavy, and I think something that's not anticipated sometimes is if the lift can get into the building, if it can get up the elevator to the floor you need, if the floors can take the weight of the lift. Sometimes the concrete can, but the final floor finish, whether it be wood or tile or whatever it is, cannot. And then one of the main difficult spaces is over stairs. We always need light over stairs, especially for emergency egress and just safety. But accessing those typically requires scaffolding. And so we really want to make sure we design in a way that is not an absolute headache later, and make sure that our clients and architects are aware of what you need for accessibility for different fixtures. So a couple examples. On the left is a library space here in New York City. There were a couple of double height and triple height spaces in this library. This is the double height one. And they did kind of decide to own a lift as a building just so that they could maintain the building. It's not just the lighting that needs maintenance, and had to make sure we could get the lift in the freight elevator to the floors we needed. We often will do minimal light fixtures over these double height spaces, but we do usually need light. What ended up happening in this space is that there are tables here, reading tables, and they primarily have task lights. So that kind of helps us balance the light we need for general light, but having the task nice and bright without needing to have a lift to maintain those fixtures as often. And on the right is a much more dramatic shot of a lift. This is for a museum here in New York City that just opened this summer. And the fixtures are primarily located for the general lighting of the space at the top in the skylight. And that center skylight is a little over 100 feet tall. And so the lift required was this enormous 100-foot tall lift. The original concept for this space was to have a catwalk to make this a lot more accessible from above. Fortunately, that just didn't work out with the way it needed to be built, and so lifts were required. Again, they had to get up in an elevator, so you're really limited to the size of the lift. And I know the electrician said they are they sway a lot at that height. It kind of felt like they had seasickness after being up there for a few hours. And so trying not to rely on some of these, if possible, can be really helpful. And then the second lift, thankfully the first and the third skylight, which you cannot see, those fixtures were accessible from only a 2.5-story space. Could be reached with a smaller lift, but we had to make sure that the bridge could hold the weight of that lift for accessibility. So it looks very dramatic, and it's also a very slow process to adjust these on lifts. So I think the time component is something that is always a factor. Number 64, we have vertical surfaces. I think the lighting handbook and a lot of the guidelines usually rely on lux levels that are at the table, the task surface, the floor. But what you actually experience in the space day to day is often what's in front of you, which is the vertical surfaces. And those can make a really dramatic impact on how you perceive a space. If you have the same amount of light, measured with a light meter, it could look really different. So if you have dark walls, that can absorb a significant amount of light. Some of the darker grays we see have like a 9% light reflectance value. So only 9% of the light that's hitting that wall is bouncing back. That light reflectance value is always something that we are looking at. Some paint companies and finish companies are really good at giving you that information. Other ones are not. So we usually try to figure out some way to approximate that. And then of course, spaces that have brighter walls, brighter finishes, a lot of that light is getting bounced back at you. It can feel like a brighter space. Even if it has a darker floor or if it's actually lower light levels, it can feel brighter just depending on what those finishes are. And I think that's something that you have to experience over time to really have a grasp on. And one of the ways that we like to test that is actually on ourselves. This is a photo of our office from a few years ago. So this is kind of the long entry wall into our office, and we've actually painted this about 6 different colors of gray with different light reflectance values going from light at the entry down to dark. And this section is lit really evenly, but you can see, it appears a lot more even, a lot brighter on those lighter surfaces. So this is a tool that we'll use, especially when we're talking to architects, to just understand kind of what finishes they're choosing, how that can feel, how this surface is getting a lot of light, but it doesn't feel like a bright surface. I have been asked before to make a charcoal gray bathroom feel bright and airy and light, and it's just a really difficult problem to solve because that requires a significant amount of light, and also not very efficient. This may be more of a US issue with some of the housing sizes. Here in the US, we have UL listings, which really restrict us on the heat coming out of a fixture, and how much heat is at the LED. And so often we will have a pretty big housing around the fixture. And I think, some of the LED sources, especially with recessed downlights, can be a pretty small aperture and feel like this small fixture, but sometimes the housing can be pretty significant behind that fixture to help dissipate that heat from the LED. And so the higher output we get, the higher powered LED, those boxes can get quite big. And especially when we have insulation contact housings, they really need to dissipate heat because that housing is touching insulation, which can be a fire hazard. So they get bigger, so the heat dissipates more, and you don't get heat at that perimeter. And so we really try to make sure we know how much space is available in the ceiling plenum. They are getting tighter and tighter these days. I've been asked many, many times, apologies, this is all in inches. A lot of architects are in the US, and so we do tend to work in imperial systems, but this is approximately 10 centimeters, 15, 16 centimeters, and a little over 20, depending on the size. And I've been asked many times to try to find something that's about 5 centimeters tall and also light a triple height space. It just is a tough ask. So often when you need shallow fixtures, you need more of them because you just can't get the output you need because of that height restriction. Beam angles, I think, is a common thing that's a little confusing when we're working with architects of just what that means. And so just a quick diagram to illustrate that the beam angle is kind of where 50% of the light is. And so after 50% of the total output, that becomes the field angle down to 10%. And so a 20-degree beam from one manufacturer does not necessarily match 20 degrees from another. That field could really range, even though they have the same beam angle, the same kind of intensity over 20 degrees. So we really like to test that in our office. We had one project where they wanted a specific beam angle for artwork, and we tested about 8 different sources. All of them had the same data as far as the specification, but they looked, widely different just based on what that beam looked like on the wall. This is a very clean version of our mock-up room. It does not usually look like this. It's a lot more cluttered often, but we have a system in the ceiling where we can put in recessed downlights, kind of suspend them between some structure, mount track fixtures, mount anything that would kind of be the ceiling plane, and light a wall. You can also see there's actually a big difference in color temperature here. Even though they might be the same color temperature kind of on the box, they might feel very different in a space. And so to see that in person is really helpful. One of these is the right selection for this project, but to see it in person is how you can decide the best. And so we'll often have architects, if it's a larger project and the fixture is being used many times throughout the project, we'll often have them come in and see what the options are, because there might be a strong preference either for the aesthetic of the fixture or the performance of the fixture that we want to review. Coves is one of the other ones that comes up a lot, especially for space concerns. We often will recommend that we give about 20 centimeters for cove heights as just kind of a starting point. This allows us to get light out of the cove. This is if especially you're using the cove as kind of a primary light source for the space, because if it is too small, that light is not really getting out of the cove. That fixture can't really see much of the ceiling and then bounce off the ceiling and into the space. If you want kind of the perimeter graphic, that small cove might be the right choice, but when we're really needing to get a lot of light out of the cove or want that really even wash of light on the ceiling, higher is better. And often we'll kind of start at recommending like 30 centimeters and then eventually get reduced down over time based on space concerns. We'll also test this in our office. This is a cove that is 30 centimeters and a little bit closer, just shy of 15 from the ceiling surface to the cove kind of plane with a lip to hide the fixture at the front. This specific fixture that we were testing at this time is a little bit atypical in that it's mounted sideways with the light source on a vertical plane lighting out. This can be a really good solution if we really need to light out into the space because it has really great throw. It's not so great if you have a tight cove because it can really get blocked by the light. So having kind of a quick tool like this to just see a relationship between what that ceiling height looks like relative to the cove is a really great tool. And then we'll often kind of stick whatever our reduced height ceiling is in here just to see, where that cutoff is, how harsh it is. This image, this Cove fixture is continuous from end to end, but you can see how much light is getting out of it depending on what that ceiling height is relative. And we'll also recommend usually holding the fixture off of the wall 15 to 30 centimeters, depending on the fixture specifically, just so that you're not getting this harsh line. But for the purposes of distribution, it's really helpful to see that line so you can see kind of what the projected throw of that fixture is. So one project that this was a big issue for was for a museum here in New York. It was actually a replica of the Oval Office, presidential office here in the US, at a slightly smaller scale, about 75% of the scale. This was as kind of more of an educational tool for the executive branch for children, which was exciting. But the Oval Office only has a cove. That's the only source in the entire space. They may bring in extra lights for TV or press recordings. There are some table lamps, but the Cove is doing all the work. So we really wanted to make sure we got the light we needed out of that Cove. So these were some diagrams we did of the height. We were recommending a 20 centimeter overall height here, with a little bit shorter with that lip height, with that fixture that is put on its side to really throw the light outward to get that soft glow. These were some calculation kind of checks we were doing for the different heights. So this is 10, 15, 20, and 30 centimeters respectively, roughly. Again, architects are working in imperial, so working with them. And this is looking up towards the ceiling of the space. So the calculation software is not great at rendering things accurately. Your eye is infinitely better at seeing this in person, but it does start to give us a sense of how much light we're getting out of the fixture at different heights. So there's perspectives of that same calculation. And then also false color renderings. This is in luminance, so in candelas per square meter. You can start to see kind of the relative intensity on that ceiling and how it's just a lot more soft at that greater Cove height. Looking down at the floor, one of the things that was really dramatic was how much light we're getting on the floor based on the different Cove heights. So that shallow height was only getting us, 210 lux, something like that. And then the greatest one was giving us, 300 lux, which is a significant jump. And so it really makes a difference how much light is getting out. Coves also have their own issues just in install. They installed them aimed up, which is completely normal. Unfortunately, not for this fixture, was not on the drawings. But when aimed down, they had not painted out the Cove as we had requested, so it got quite orange on the ceiling. And so that was one of the things we had to check in our punch list. And so you can see this is a quick image of oriented correctly, oriented up, and how much more even that is. We also put, this has some adjustment, and so in the field, we adjusted it to find kind of what the sweet spot is for that aiming angle that made the most sense. So we were adjusting all of these. You can also see Coves are also tend to be the leftover last thing cleaned, and so there's a lot of plaster dust, things caught in the Cove. So Coves can be a great solution. They do come with their problems. So this is me actually adjusting these. So this was 3 different angles. We adjust maybe 2 to 3 meters of a fixture just so we can really see the impact of different angles and what that looks like. Step back and choose which one looks the best and then match that throughout. And so this is looking up. These all on the left image, the right side of the image, those have all been adjusted to kind of the correct angle that we found. And then the last section has not, then on the final image looking up. And one of the things, because there is this executive branch medallion in the center, we really wanted to make sure it was evenly lit all the way through. The blue is from, they're actually faux windows in 5000K. It does actually feel like there's daylight coming through there. but you can really see the shift of color, which we really found fascinating. I don't know that anyone else cared, but we found just that kind of simulated light really, really fascinating. So this is an image, kind of a press image of the final space. They did add exhibit case lighting because this is an exhibit for a museum to the shelves. They do not exist in the actual Oval Office. And of course, these are not real windows, but the Cove came out really nicely. Another thing with just kind of your angle of light that we find is wall grazing. This can be such a great tool to highlight the texture of a wall if a wall is textured, especially for brick or stone. Certain stones, we really want to bring out that texture. It creates this really lovely interest to the space, but it can also bring out texture you do not want. And so I think understanding that if it's a wall that may not be perfectly smooth, a grazing light might not be the best choice. So on the left, we have a brick wall. This is a museum in New York in progress shot with all of the construction equipment in front of it. There's a light source hidden behind the ductwork here, grazing down the wall. The building is about 200 years old, which for New York is an older building. So we really wanted to bring out the character of that brick. This is also the backdrop for an exhibit multi-purpose space. And on the right side, this is a plaster wall, which shouldn't really have grazing light on it, or it should have them come and refinish the plaster. So we will find sometimes if there is a wash of light on the wall, once that gets turned on, the plaster work starts to get fixed because they're seeing imperfections they didn't see before. Similar with lighting a wall or surface, color really makes a difference. So color changing lights, we don't work with an enormous amount just because of the types of projects that we work on, but we have worked with them, especially for, there's a children's library working on right now. There's some color changing lights there. We really use it as a really fun layer of light for specific projects. But one of the things we always want to make sure is what is that source lighting and how is that affecting how you see that color. And so especially dark finishes really absorb all of that color. You're not seeing the saturation of the color. We want to make sure you really see that light well and really see the shift in color if that's what wants to be seen. One of the things that comes up a lot is maybe the wall is a color and they want to use color changing lights on the wall. And so it's a little hard to show them sometimes that this doesn't work the way they might think it works. So a quick kind of diagram of that is, if you're lighting fruit with a blue light, like it's not going to look like natural fruit. We also did this in our office with just color swatches. So this is a light bulb that could shift through different colors. These fabrics are green, yellow, red, and blue, respectively. Certain fixtures, kind of the more yellow, orange, light, you can kind of see that those are the colors. But in green and red, those colors are really not coming through as true. And then with magenta, blue, and then white, you can see the true colors. And so one project that this came up was for this library here in New York. It has this very dramatic peaked roof, but it is in green. They wanted it to look like, kind of mimic the patina colors of the roofs around. But there was at some point interest in making this color changing so that they could kind of affect the color of light, make it pink for Valentine's Day. And pink for Valentine's Day on a green roof tends to be more of a brown, which is not as festive. So what we did do is go towards a tunable white light so that we could shift the color to make that green look the way they wanted it to. And so we were able to come up with architect, adjust the light through the different colors of white, see what was preferred. And the final one, I don't remember the specific color temperature, but was on the cooler side, and that just fit better with the overall appearance of the building at night. Another thing we work with a lot is case lighting, which is a lot to coordinate. Lighting from outside the case, if you have a case in space and your lighting is coming from track fixtures on the outside or recessed lights, that's the cheapest. You don't have to integrate lights into the cases, but this can be really problematic just because of the reflections of the lights or neighboring walls, things, etc., on that case. We find that sometimes the objects can be lost. Often objects in cases have light level restrictions. And so we can only put so much light on them to begin with. And so if you're competing with an outside space that has a lot of light in it, that object might be lost. And we don't want that to happen. We don't want the light to be a distraction. You can also get reflections of the glazing of the case onto the floor, onto adjacent cases. You can get projections of the structure of the case, beyond the case, within the case. It's really hard to anticipate as well without a mock-up. So often we advocate for internal lighting just because it does provide the best light source for many objects and cases, but it does require a lot more coordination. For certain objects, they cannot handle the heat of even LEDs in a case, so we have to go with fiber optic. There are still problems there. You'll get, the reflection of whatever's bright in the case within the glazing of the case. You might have aiming issues of being able to see into the light fixtures from the outside. But often we can put a lot less light on the object and still make it prominent, which can be a really good solution for some museums. So a couple of different examples of this. This is for a nonprofit gallery here in New York. This is on the left side, unaimed or unfocused light, and then on the right side is focused. They preferred pretty bright light levels in the space, which also means that the walls, which were primarily white, are getting reflected in the cases themselves. And so there are a lot more reflections. The case edges are pretty minimal, so we weren't getting too many case shadows there, but you can see the objects in the case kind of are competing with all of those reflections around them. Whereas these ones, which have no case, are really easy to see in the back. We'll also find track fixtures that are aimed above the case. You'll get a projection of light. It's a little difficult to see on this one, but there is a band of light of just the light that's bouncing off of the top of this case and onto the ceiling. If those track fixtures are dimmed kind of all the way up, this can be a really distracting graphic on the ceiling. So it's always something we balance, but it's definitely successful. It really worked for what we needed. We were able to achieve the light levels required for these specific pieces, which were around 200 and 250 lux was kind of the target for these pottery pieces. But it's always a challenge to balance that. And then on the other side, this is a case that has integrated lighting. This is for another museum in New York. These objects had very low light level requirements. There are some objects in here that had, under 50 lux as a requirement. They cannot be in light for very long, but we also want to make sure that you can see those objects. And so what helped us here was that we had a dark background to work with. The objects could kind of pop off of that. We were really grateful for that. And we had fixtures kind of down the side. So this is the unaimed case. The fixtures are off. You can see, you're kind of seeing all the reflections of everything beyond it. Really hard to see the objects in the case. This is kind of during the aiming, also to get a sense of scale. So that's a person standing in front. So they're pretty big cases with pretty tiny fixtures. And we're able to start to aim these at all of these objects. And then this is kind of looking straight on. You will see that there are some reflections. There's some window niches beyond that are lit that we did dim down, but there are some distracting reflections, but it's pretty minimal in terms of what could be there, especially if it was lit from the outside. And then with cases. Art, depending on what it is, really requires different light levels. If you're a lot of sculptures were made to be outside, they can handle kind of whatever light is thrown at it. They don't age dramatically in the light. Those are always easier pieces to light because I'm not as restricted. There's always a issue of time as well. So how much time the piece is in light, how that light can degrade it over time. Some museums or collectors we found will actually light things to a higher light level, but reduce the amount of time it's visible to the public, or has light on it at home so that they can see it in the bright light that they want to. But overall, the overall lux hours are reduced so that they're not kind of exceeding these recommendations. And it is always specific. These are kind of general guidelines. We always ask curators what their targets are for the specific objects, because we don't always know what everything's made of. On the previous case, there were some things that there was a tiny spoon made out of an eagle talon, and I would have never guessed that. And so to have kind of the understanding of what the materials are, what the limitations are, especially to UV. Thankfully, UV is not as much of a problem with LEDs, but if there's daylight in the space, that can be really problematic. Works on paper especially are exceptionally fragile, and we find they can actually color shift significantly if they're exposed to too much light. So we don't want to conflict with any of that. We really want to respect the artwork and really keep that in mind. So these are a couple different, it's actually the same space, different shows. The sculpture on the left is made of concrete. It did not need specific light level limitations. We could go up to 1,000 lux easily with no issue. And so we like to measure still just to understand how much light is falling on it and how even that light is, especially if it's an object that has different colors throughout the piece. It's hard to sometimes gauge, is this even? Is it getting the even amount of light that we need? And on the right side is a painting. It's actually under a skylight, so we were concerned about how much light it was getting. So we're measuring here at the surface. It may look like he's touching it. We're always really careful to make sure we're hovering kind of as close to the piece as possible to get an accurate reading, but far enough away so that we're never touching the piece. I'll often brace my arm just to make sure that's not a possibility. So this one, we were targeting 200 lux or less, if possible there. For this one, they did open the skylights at some time, but they will close them for the majority. So it's kind of, again, playing with that lux hours, reducing the amount of time it's exposed to UV overall, even though it is exposed at some points. So this is actually that same space with the pottery collection. So this is with that skylight open. You can also see the dramatic difference in color temperature from kind of the midday sun. And then the warmer color of the lights inside. This is not fully aimed at this photo. And then on the right side, this is fully aimed. And so this one had relatively limited light levels, 150 to 200 lux. And so we had to measure each and every piece, the sides of the pieces, just to make sure we are not degrading those materials over time. I do see a question about UV. So our meters are just measuring the light output, which is measured in lux, or in some cases in foot candles for us. We will also measure kind of what the color temperature is and the source, but we do have a separate meter for UV. It's less common. There were some fixtures for a while, especially metal halide, that had UV in them. And so you had to use filters to really filter that out to make sure you were not getting any on the artwork. LEDs typically do not have UV. Most of the blue sources that they're using do not skew low enough in kind of wavelength to skew into UV. So that's not as much of a problem. What we find is often the problem is daylight within a museum space and how much UV that's getting. So we do have a UV meter that's measuring that over time. It's always a range that the curators have to give us how much it can take. So we will usually default to them on what they prefer. And then speaking of daylight, this is maybe an atypical solution, but we really have fun understanding daylight as well. That's one of the things we really enjoy working with. The sun is just such a wonderful tool to work with when we have the opportunity to work with it. So this kind of slides page came from our office when we were moving in about 10 years ago. You were noticing, it's unfortunately a cloudy day, so you can't really see, but the buildings adjacent to us, when it was sunny, all of their shades were down. And so they're not really seeing the outdoors. They're not really seeing the sky when it's bright out. You're really mitigating the sun and blocking it for the most part. And so we thought it would be wonderful to create a solution that worked with the sun, used the power of the sun, and also gave us an opportunity to see outside to the skyline beyond us. It's not in this room. This room is north facing, so it's a lot less of a problem in terms of light. But when you have direct sunlight, you'll get that band of this person closest to the window is in direct sun. It might be hot. It might be too high contrast, especially for screens. Screens in direct sun are really hard to read. And someone just out of that range, it might be too dark and they have to use task light. And so to really even that out, to bounce the light onto the ceiling can really mitigate that, make it a lot more of an enjoyable environment. At least for us, that was the choice. So these are some quick photos of this system we made. It is not a commercial system, nor quick to put together, but we find it really fascinating and fun to play with and understand. So we have a few different exposures in our office. This is the southern exposure. New York is not straight north-south, so this is actually a true south exposure. Manhattan's on kind of a 23.5 degree angle. So these reflectors are at kind of a 4-inch interval. The vertical ones are kind of blocking the lateral light from coming in as the sun tracks through the sky. And then the kind of horizontal elements are kind of seeing the sun, catching the sun, and bouncing it up to our ceiling. So this is kind of the southwest exposure. It has a slightly different shape to it. And you can see the bottom half is left open. We have no desks directly next to the window, so we can walk through that space. So we do get direct sun on the floor there, but the upper half, we are bouncing all of that light onto the ceiling. So most of the time, these are linear indirect light fixtures. Often they do not turn on because we get enough light, especially in this half of the room closest to the windows. But on a gloomy day, we'll have to turn them on. We're not getting a lot of light, but it can be really beautiful to see kind of the light track across these. We have fun putting, dichroic film in some of them and making color. So it's a really fun way to use the tool of sunlight. We just find it really endlessly fascinating. So I think that's all. So it's not all of the tips. You're welcome to view those on our website as just renfrodesign.com. So you don't have to buy the book to see them all. But yeah, it's just a taste of it. We really enjoy putting it together. It's amazing. It's been 5 years. So, but yeah, happy to answer any questions. I'll look through the ones on the side.
Angie, thank you very much.